Hi everyone, in this video we're going to continue learning about probability and we're going to talk about independence and multiplication rule. So let's first identify independent events. Two events, we're going to call them E and F, are independent if the occurrence of event E in a probability experiment doesn't affect the probability of the other event, event F. Two events are dependent if the occurrence of one event, we'll say E, in the experiment actually affects the probability of the other event. So let's decide if this is independent or not. Suppose you flip a coin and you roll a die. The events obtain a head and roll a 5 are independent because the results of the coin flip don't affect the results of the die toss. Let's look at B. Are the events earned a bachelor's degree and earn more than $100,000 per year independent? The answer is no, because knowing that an individual has a bachelor's degree affects the likelihood that the individual is earning more than $100,000 per year. Let's take a look at C. Two 24-year-old male drivers who live in the U.S. are randomly selected. The events: male 1 gets in a car accident during the year and male 2 gets in a car accident during the year are independent because the males were randomly selected. So this means that what happens with one of the drivers actually has nothing to do with what happens to the other driver. So disjoint events versus independent events. Disjoint events and independent events are different concepts. So recall that two events are disjoint, or another way to say that is mutually exclusive, if they have no common outcomes. So that's the same thing as saying if knowing that one of the events occurs, we know that the other event did not occur. Independence means that one event occurring does not affect the probability of the other event occurring. Therefore, knowing the two events are disjoint means that the events are not independent. Next, let's use the multiplication rule for independent events. Here's our rule. If events E and F are independent events, then if you wanted to find the probability of their overlap, the probability of event E and event F occurring, then what you can do is you can actually multiply the individual probabilities. So it would be probability of event E times probability of event F, and that would give you the probability of E and F. So let's take a look at this example. In the game of roulette, the wheel has slots numbered 0, 00, and 1 through 36. A metal ball rolls around a wheel until it falls into one of the numbered slots. What's the probability that the ball will land in the slot numbered 21 twice in a row? Okay, so there's 38 possible outcomes because we had 1 through 36 and then 0 and 00. So the probability of landing on 21 is 1 out of the 38 possible outcomes. Now, because the events 21 on spin 1 and 21 on spin 2 are independent, then we can use our multiplication rule. We're looking for the overlap, or the AND, of these two events. And the way we do that is by our rule of multiplying the individual probabilities. And so we have the probability of 1 out of 38 times same probability for spin 2. And so that's 1 out of 1,444, which is about 0.0006925, or 0.6069%. So very, very small probability that this would occur. So the way you could say that is we expect the ball to land on 21 twice in a row, about 7 times, because that's the, if you round 69, you could just round that to 7. And then if you move over enough decimal places, that would be out of 10,000 trials. So 7 out of 10,000 that would occur. So here's our multiplication rule for n independent events. We had just looked at 2 independent events. Now we're generalizing this to any number n. So if we have our events, event 1, 2, and so on, up to event n, as long as they're independent, then the probability of event 1 and event 2 and so on, their overlap, is just the multiplication of the individual probabilities. So let's take a look at this one. The probability that a randomly selected 24-year-old male will survive the year is about 99.86%, according to the National Vital Statistics Report. What is the probability that 3 randomly selected 24-year-old males will survive the year? So the probability that all 3 males will survive is actually the combination of the first surviving and the second surviving and the third surviving. So the overlap of all 3 of them surviving. And by our multiplication rule, we just multiply the individual probabilities, and we get that this probability is 99.58% likely. So if we randomly selected 3 24-year-old males from 1,000 different times, we would expect all 3 of them to survive at a 996 times from the sample. Now let's find the probability that 20 randomly selected 24-year-old males will survive the year. So we just changed our number from 3 to 20. Okay, so same thing, probability of the first surviving and the second and so on to the 20th. So overlap of all of them is just the product of all their probabilities individually. And so the way you can shorten this calculation, let's say you do it on the calculator, is we're multiplying the same probability 20 times. So we could just say this probability to the 20th power, which is going to be 97.24%. And so if we randomly selected 20 24-year-old males 1,000 different times, we would expect that all of them would survive in the year if out of 972 of those samples. Now let's compute at least probabilities. So compute the probability that at least 1 male out of 1,000 aged 24 will die during the course of the year if the probability that a randomly selected 24-year-old male survives the year is 99.86%. Okay, so we learned about complements in the last video, and so we only know the probability that the male survives. So to get that he actually wouldn't survive, we have to do the complement. So 1 minus the probability that no one dies, they all survive. That's our complement rule. And so now we're combining our complement rule with our multiplication rule. So 1 minus the probability that the first survives and the second and so on to the 1,000th surviving. Okay, so then using our probability rule, we take the individual probabilities of the first surviving times the second all the way to the 1,000th surviving. We multiply those, and the short way to do that is that since it's the same probability for each one, we're just going to raise that probability to the 1,000th power. And then 1 minus that number gives us 70.7536 or 75.36%. So if we randomly selected 1,000 males 24 years of age, and we did this 100 different times, we would expect at least 1 to not survive in 75 of the samples. All right, now let's sum up our probability rules that we've learned so far. So the first one, the probability of any event must be between 0 and 1. Okay, remember we talked about this, including 0 and 1. The probability that something occurs can be that 0% of the time it will occur, all the way up to 100% of the time it will occur. Number 2, the sum of the probabilities of all outcomes in a sample space has to equal 1. So all of your probabilities of each of your events, when you add them up, the total is always going to be 1. 3, if 2 events, we're saying E and F, if they're disjoint, then the probability of E or F is the addition of the 2 individual probabilities. If they're not disjoint, then the probability of E or F is the addition of the 2 individual probabilities, but we have to subtract the overlap. Okay, so this is minus the probability of E and F occurring. Number 4, if E represents an event and E complement represents the complement of E, then the probability of the complement is always 1 minus the probability of the event. And then 5, if the events E and F are independent, then the probability of E and F is just the product of the two individual events. So notice that OR probabilities use the addition rule. So back up here, this was OR, and we were adding, OR, and we were adding. And then AND probabilities use a multiplication rule. So AND right here when we multiplied. So accordingly, OR probabilities imply addition, and AND probabilities imply multiplication. So just a quick reminder, AND is when they overlap. Something and something else occurs simultaneously. OR just means one or the other. Okay, thanks for watching. That's it for this one.